Okay, so exponential and logarithmic functions, we're going to do a little bit of review here. So with exponents, if you want to remember, if the bases are the same, you keep the base. So we'll keep the 4, and then we add the exponents. So sometimes that's tricky for people. They say, well, why don't you multiply the 4 and 4 and get 16? It's kind of like if you had like an x to the second times an x to the third, let's say, right? It would be an x to the fifth. So you just keep the x's, you keep the x, and you add the exponents. Division, you subtract, so this would be 4 to the x minus 2. So again, keep the base. So if it was x to the y, let's say, over x to the second, it would be x to the y minus 2, right? You'd subtract exponents. Power raised to a power, you multiply. So this is 4 to the 2x, x times 2. Reminder of negative exponents, 2 to the negative 4 is 1 over 2 to the positive 4. You flip the base, you flip the 2 to 1/2, and then the exponent becomes positive. So this is then 1/16. You could first say 1 over 2 all raised to the 4th. So you flip the base, you flip the 2 to 1/2, and then you raise it to the positive 4th. 1 to the 4th, 1 to any power is 1. This is 4 to the 1.5. 1.5 I would think of as 3/2. So if I'm trying to do this without a calculator, which remember you should be challenging yourself to do things without a calculator for preparation for college. So then this would be the square root of 4 and then cubed. 2 cubed is 8. So square root of 4 is 2, 2 cubed is 8. This again, when I first look at it, it seems like, oh wait, I need a calculator. No. If I think of negative 0.5 as negative 1/2, now I should be able to handle that. 9 to the negative 1/2 is 1 over 9 to the positive 1/2. You flip the base, the exponent becomes positive. So this means the square root of a 9th, which is a 3rd. Remember, to the 1/2 power means square root. To the 1/3 power means cubic root. To the 1/4 power means 4th root. A function in the form f of x equals b to the x, where b is greater than 0, is called an exponential function with base b. So 2 to the x, so this scenario, we're going to look if b is greater than 1. So the base is greater than 1. It's a 2. So then our exponential function looks like this. It goes through 0, 1. What you should know here is there is a horizontal asymptote at y equals 0. So it's kind of understood that there's an asymptote here. Domain is all reals. Range is just soft bracket 0 to infinity. So it lies completely above the x-axis. Now, if b is between 0 and 1, which is this scenario, b is a 1/2, then still goes through 0, 1, but it's decreasing from left to right. So domain is still all reals, range is still 0 to infinity, soft bracket on the 0, horizontal asymptote is still at y equals 0. The only difference, one of them's increasing, the other one's decreasing. Logarithmic and exponential functions are inverses of each other. Therefore, graphically, a function and its inverse can be shown as a reflection over the line y equals x. So if I said an exponential function looks like this. So let's say this is y equals b to the x, some base b to the x power. Then if I reflect over the line y equals x, my logarithmic function will go through 1, 0 and look like this. This is y equals log base b to the x. And a log domain is 0 to infinity, range is all reals, and there's a vertical asymptote at x equals 0. So if you think about it, it makes sense. Since you're reflecting over y equals x, if you think back to your geometry days, a reflection over y equals x swapped your x and y coordinates. So it makes sense that the domain of an exponential is then the range of the inverse, and the range of the exponential is the domain of the inverse. And instead of a horizontal asymptote, we have a vertical asymptote. So a log graph, just to be clear, there's a vertical asymptote at x equals 0. And then, it's kind of looking like this. That's your log graph. Okay, they say if b is greater than 0, b does not equal 1, a is greater than 0, c is greater than 0, and r is any real number, then. So you should know these rules. It's your product rule of logs. If you have log base b of a product, that can be written into the sum of two logs. Log base b of a quotient, difference of two logs. Log base b of some power gets multiplied, and log base b of a quotient, if the numerator is 1, so I should say log base b of 1 over some whatever, variable, constant, whatever it is, then that will be raised to the -1, which then power rule, or we could think of power rule from like up above. The -1 would come in front. This is called, though, the reciprocal rule, just knowing if it's 1 over c, that you're going to get negative log base b of c. If you think about it, just to talk a little bit more about this one, because we said log base b, so up here the quotient rule, said log base b of a quotient, right? That's log base b of 1 minus log base b of c, right? That's how we could write it based on this rule up here. Log base b of 1, though, is 0 because it's saying b to what power gives you 1. So remember with logs, like when you would do a log, last year we would talk about the lasso method. We would say b to what power is 1. B to the what power is 1. That would be 0. So this is 0 minus log base b of c, which is just negative log base b of c. So that's where the reciprocal rule is coming from. It's really coming from the quotient rule. Some important ones, ln e is 1, right? Because ln is a log with base e. So that means e to what power is e? E to the what power is e? Well, that would be e to the first, right? So x is 1, that type of thing. This is a log again, base e. ln means log base e, so it's saying e to the x is e to the x. Here they want you to know when you have, I'm going to just spread it out a little bit. Here, e to the ln x. They want you to realize ln is a log with base e. So if you have this whole thing is a power with a base of e, If you have a power with the base of e and a log with the base of e, these kind of are inverses, so they cancel each other out, and you're just left with the x. So we're going to see some examples like that. So for this one, this is the log of 1 over 10 to the third, right? 1,000 is 10 to the third, so this is a log of 10 to the negative third. If I want to flip that up, 10 to the third on the bottom is 10 to the negative third. This is log, when they don't write the base, is base 10. So this is a log with base 10. This is an exponent, a power with base 10. So those cancel each other out, and you just get negative 3. A log with the base of 10, an exponent with the base of 10, cancel each other out, you get the negative 3. ln is a log with a base of e. So a log with a base e and a power with a base of e cancel each other out, and you just get 3. This is ln. Again, this is a base of e. And then radical e is e to the 1/2 power, right? Or square root of e is e to the 1/2 power. Log with base e, x power with base e. So hopefully you're kind of seeing this is a log with a base of e here. This is a power with a base of e. So the log, since we're doing the log base e of the power base e, those are just canceling out and giving me a 1/2 as an answer. Okay, next one. The negative can come back, and this is e ln of x to the negative 2. Which then e ln base e cancel each other out. You get x to the negative 2, which is 1 over x to the positive 2. Again, this is ln base e. This is an exponent base e. They cancel each other out. You get negative x squared. This is ln of e to the negative x, right? 1 over e to the x can also be written e to the negative x, because you're flipping the e to the x up, which means it gets, the exponent gets negated. And then ln and e cancel each other out, because ln is a log with base e. This is a power with a base of e. So they cancel each other out, and we just have negative x. This is e to the, okay, so if we think of our, going back up here, this rule, this can be condensed. So this right now is separated like this. We can condense it to something back like the previous. So this is ln of 2x, right? We take this a and this c from up above, and we multiply them together. So x and the 2 is 2x. And then e to the ln, remember this is a log with base e. So an exponent base e, log base e cancel each other out, and I get 2x. Log and x, ln and e cancel each other out. This is just x minus x squared. This is the product, ln of a product. So again, remember you can write this as the sum of 2 logs. So that's using our product rule. Then from there, I can use my power rule, bring the 2 in front, bring the negative 2x in front. And then if I realize, or I need to realize that ln of e is 1, That would be my simplified answer. E to a sum. Now, this might be a little bit tricky. Like if you think about it, if I did e to the x times e to the 2, I could write that as e to the x plus 2, right? When I'm multiplying, I add the exponents. I keep the base, I add the exponents. So this is e to the x, I'm kind of working backwards, times e to the ln x. So I'm kind of going in the reversed order of where we would normally go. And I'm doing that so that I could then simplify these. So this is e to the x times this, remember, power with base e, log with base e cancel each other out, and we just get x. So this is x e to the x. Now, I'm going to use the same type of thinking here. So we know if we have e to the x over e to the second, let's say, we write that as e to the x minus 2, right? We keep the base, we subtract the exponents. So for this one, I'm going to do kind of a working backwards. E to the ln x over e to the, I'm going to reverse that power rule too. So e to the ln of y squared. So whenever you have a constant in front of the ln, you should reverse that power rule. Bring the 2 comes back and becomes the exponent. So now I can simplify each of these. E to the ln x is just x. E to the ln y squared is just y squared. Because e to the ln is log base e. All right, to look at a little bit of solving, when we talked about solving of log equations, there's 3 types. One is where log's on one side. So that's like these next 2. Log's on one side, so I have to take the base, which here, remember when they write log with no base, it's a base 10. So you go 10 to the third equals x plus 1. 1,000 equals x plus 1 minus 1. X is 999. Now, with log equations, you do have to check because the domain, remember, the thing you're taking the log of has to be greater than or equal to 1. So for the domain of this one, x plus 1, or I'm sorry, what did I just say? Has to be greater than 0. X plus 1 has to be greater than 0. X is greater than negative 1. As long as my answer is greater than negative 1 then here, I'm good. So always the thing you're taking the log of cannot be 0 or negative. This is ln. ln is a log with base e. E to the 4th equals x squared. If I square root in an equation, x is plus or minus e squared. Right? Square root of e to the 4th is e squared. We need the plus or minus because it's in an equation that we're square rooting. All right, now I'm getting to one where there's logs on both sides. There's logs on both sides. We know eventually we can drop off log, solve. But we cannot drop off log until we've gotten both sides completely simplified using all properties of logs. So if I have the sum of 2 logs, to condense this to a single log, ln, and we multiply, right? 2x cubed times a 1 over x. So again, sum of 2 logs gets condensed to a single log by multiplication. So this is ln of 2x squared, right? If you're simplifying there, putting this over 1 You can reduce that and then multiply straight across. Okay, so once you do that, now this left side is as simple as it's going to get, so is the right. There's no more property of logs to use. So 2x squared equals 3, x squared is 3 halves, square root, so x is plus or minus radical 3 over radical 2, which when I rationalize is plus or minus radical 6 over 2. Now, I remember I can't take the log of a negative or a 0. So if I put my values up here for x, I have to ask myself, am I taking the log of something 0 or negative? Well, if I put in negative radical 6 over 2 up here, then I would be taking the log of something negative. So I have to reject the negative, and my answer is x. I would say my answer is radical 6 over 2 positive. I have to reject the negative there. I only reject the negative if it's making me take the log of something negative when I plug it in up top. Next one is a log with base e, or I'm sorry, it's not a log. It's a exponential function base e. So the way you solve an exponential function is you take the log. So since this is base e, we're going to take the ln. So I'm going to do the ln of both sides. On the right or on the left-hand side, I can use power rule, which brings the power in front. Ln e, remember, is 1. So this is just 1. So then I really just have on the left-hand side x minus 2 equals ln 3. So x is ln 3 plus 2. Exponential functions, remember, the domain is all reals, so you're not going to have to ever worry about rejecting anything. This is another exponential function. Base is a 4. So the way I solve an exponential, the way I solve an equation is to do its inverse. So I'm going to take the log. I take the log of both sides. Then I use power rule of logs to bring that x in front. And then I'm going to solve for x by dividing by log 4. Log 7 over log 4. Or if you remember from last year, change a base formula says that that's equivalent to log base 4 of 7. So either or is fine. And the last one kind of goes back to this example back here, where we have logs on both sides, but we've got to get this condensed down to a single log. So first thing I would do is I'm going to leave this ln 4x right now. This I have to reverse power rule. So this becomes minus ln of x squared to the third. Which is ln 4x minus ln of x to the 6th. So, right, reversing that power rule, that then becomes, that's taken to the third. Power to a power, you multiply. So if I'm taking it to the third, I multiply those. Now, this is a subtraction of 2 logs. A subtraction of 2 logs gets condensed to a single log by doing division. Okay, and then if I reduce here, So this will be ln of 4 over x to the 5th equals ln 2. I'll just do that so it's in the same color. Okay, and now that I have log, single log on both sides, condensed, I've used all my properties of logs that I can, I'm going to equate the two things I'm taking the log of. And then cross multiply. I'm going to come over here just because I'm running out of room. So this is 2x to the 5th equals 4. Divide by 2, that means x to the 5th would be 2. X equals then the 5th root of 2. So you take the 5th root of both sides. And 5th root of 2 will be our answer. Okay, that's it for the day 5.